As an Ansys partner since 1984, we are highly committed to helping you design, simulate, and succeed.
Hello everyone, this is Alex Austin, Structural Group Lead for DRD Technology. I'll be talking about an application example, a fatigue fracture of an airframe bulkhead beam. The objective of this application, this simulation that we'll be running, is to simulate a fatigue crack growth test of an airframe bulkhead beam and to determine where the crack grows and the rate at which it grows. This is similar to the statically loaded fatigue fracture test that we simulated before. In this case, however, we are cyclically loading the beam with this pressure load, the 0.1 megapascal pressure load. So again, this beam is fixed on the top and bottom. We have the pressure load on the back side, the red phase that you see there, and then we have a crack inserted into the structure where this green surface in this graphic overlaps the solid part. That is where the crack is located. Now, how does Ansys solve for crack growth? We touched on this previously in the static case, but for the fatigue case, it's largely the same. Ansys will automatically grow the crack from its current location in a given step based on the load. It will determine the direction of crack growth from the far-field stresses, and then we'll also determine the stress intensity factor or the fracture parameter that describes the crack behavior itself. So Ansys can grow the crack in general 3D geometry in all three modes of loading. Now what that looks like in simulation, this animation here, the crack starts on the left and grows to the right. And you can see that as the simulation marches forward, each individual time step, Ansys will calculate the crack growth, grow the crack one element, and repeat the calculation however many number of times you specify. From this simulation, Ansys will determine the number of cycles for growth, the crack extension, of course, which is going to be linked to the element size, as well as the stress intensity factor. This is done automatically. General 3D remeshing is required to handle this, and all of this is done at the solver level. Now for fatigue fracture, if we look at the full crack growth rate curve, so this is crack growth rate versus the stress intensity factor range, the default behavior in a fatigue and fracture analysis is to capture the middle section here. This is region 2, or the power law region. So Ansys assumes that there is a linear relationship on a log-log plot anyway between the crack growth rate and the delta K. Now in this particular case, we can also capture the threshold delta K value. So effectively this crack growth curve would extend in either direction, however large the delta K is going to be. However, we can stop the crack growth by assuming a minimum delta K that is required for the crack to actually grow. If that occurs, then the crack stops growing. In this example here, we input just the two material parameters required to define that region 2 behavior, or typically referred to as Paris law, as well as the threshold delta K, that if the stress intensity factor falls below that value, then the crack would stop growing. In this example here, we start with the crack growing at that one spot. The crack grows out. You can see it kind of angled downward. It gets to the crack arrestment location here. I'll go ahead and play that again. And the crack stops growing. This is just one instance of a fatigue fracture analysis we can do in Ansys. For more information, for a couple webinars, as well as a fracture mechanics training course, visit our website, drd.com/resources, as well as drd.com/training.
Contact us today to discuss your unique physics challenges and find the right Ansys tools for you.